Hey, hello, good evening. Could you hear me? Yes, okay, cool. Let's also check the lecture slide. Could you see the lecture slide? Yes, okay, perfect. 4 minutes to go. Thank you. Two minutes to go. 2 minutes. Oops, I have to turn on the aircon again. Just a minute. Hello, I'm back. The time now is 1 minute past 7. Let's begin. Once again, thanks for coming. This is the second review session and essentially should be the last one. All right. So after these two review sessions, I hope that you have a better understanding on pointers and references. All right. Hey, by the way, have you had your dinner yet? Yes, good. No. Okay, eating now, good. Yeah, you can do both at the same time, attending the review session and eat your dinner. All right. Okay, so if I'm not mistaken, I stopped here yesterday. Basically, the main idea here is something like this. We can definitely put negative index in the square bracket. In some other programming languages like Java, we are not allowed to use negative index because no pointer there. But in C++, we could use pointer, right? Then it makes sense to put negative index. But still, you need to be careful. Why? Because if you put invalid index value such that you try to access some out of bound location, then you are going to get trouble. Do you know what I'm saying? So let me say one more time. For example, P is pointing at some box, right? And if you move the pointer and go out of the bound and access the box, you may get runtime error. In other words, you need to make sure that you do the right thing. All right. One thing that is really good for Sing is Sing would help you check out of bound access. Do you know what I'm saying? For example, if you have installed VS Code on your laptop, then you should be able to use a G++ compiler. But it doesn't mean that the VS Code would help you check out of bound access. But for Sing, we install one thing called sanitizer. Why we install sanitizer? Because we want to help you to check illegal access or out of bound access. So in other words, I strongly recommend you to submit your work to Sing and do checking. All right. I guess we will set up something there so as to help you check out of bound access. Okay, good. So far, so good, everyone. Okay, next. Wow, you see the dog is pretty cool, huh? Sunglasses, pretty cool. And what I want to say here is square brackets is actually something equivalent to move and follow the arrow. In other words, if you have a pointer, you can do addition to move the pointer. You can do dereference to follow the arrow so that you can get the box, right? But there is a cool operator that can help you to do both. That is square bracket. All right. So if you can do this, you can actually do the same thing like this. So my question is, which one do you like most? Number one or number two? If you can do either one to access the box, which one are you going to do? I think the first one is better. Yeah, because one symbol or one operator do two things: move and follow the arrow, reach the target, grab it. All right. So most people do this one, but some people, they do this one instead because they want to show off. They want to show other people, yeah, they are really good. They can do this without square bracket. But what's the point? I think this is something more readable. Okay. Have you learned all this yesterday? I think so. You have learned all this yesterday. So basically, this is just a recap. All right. Wow. How about this? This is the new thing that I want to talk here. And what is this? Int asterisk p square bracket 3. If you only take a look at this part, int star p, definitely p is a pointer. But if you put square bracket and a number in it, this is an array of pointers. Array of pointers. This array, how many boxes? 3. And the name of this array is kind of P. But each of this box is a pointer. In other words, we can store an address here, we can store an address here, we can store an address here. All right? All the boxes are pointers, are pointer variables. So that's why I can do this. Grab the address of A, put it in the first box. Grab the address of B, put it in the second box. Grab the address of C, put it in the third box. All right? So this is how we define an array of pointers. Okay? Yes or no, everyone? Hey, by the way, do you want to learn more? Please say yes. Let me show you something interesting. Like this. Is this something similar to this one? Is this similar to this one? Please say yes, very similar. What is the difference? Spot the difference. Spot the difference. This one and this one, the difference is you put parentheses. You use the parentheses to enclose asterisk P. Then are they the same? No, they are different. What's the difference? What's the difference? The difference is this is an array of pointers, right? But this is a pointer to an array of 3 boxes, and each box is int. Hey, do you know what I'm saying? Do you know what I'm saying? I think the syntax is very confusing, but these two are different. Let me say one more time. This one is array of pointers. Array of pointers. 3 pointers here. Okay, but for this one is a pointer to an array with 3 boxes, and each is int. Yeah, I'm not kidding. This is a pointer that can be used to point at an array of 3 boxes, and all 3 boxes are ints. Do you know what I'm saying? Do you know what I'm saying? Yeah? Okay, very good question. If you dereference P, this one, then actually refer to the whole array. Refer to the whole array. Yes. Yes. So this is fun. This is really interesting. All right. Hey, no worry. You are going to see how we use it later on in class. I will definitely give you more information about this. So this is actually the dessert. Yeah, for those of you who have finished, yeah, your dinner, then this is the dessert. You learn more, huh? Or still main course? Good. All right, no worry. This is a more advanced feature in C++, but this is something fundamental. All right. Okay. Now I want to introduce you one guy called null pointer. You may say, I know null pointer very well. Oh, by the way, okay. A question. Is it the same as int p3? Not exactly the same, not exactly the same, not exactly the same, but very similar in terms of behavior. Actually, you asked a good question. Yeah. So please allow me to give you more details later in class. Yeah, because we do have a topic about this. All right, good. Okay, everyone, let me talk about null pointer. You are going to say, Desmond, I know what is null pointer. I know better than you do, right? Hey, but I'm going to give you more information. Null pointer, N-U-L-L-P-T-R, null pointer is something like address 0, something like address 0. In other words, it's the top most location address. And in other words, in our memory, there are many boxes, right? The very first box has address 0. Okay. And no matter what kind of system you are using, there is one thing for sure. The box with address 0, we are not going to use it. We are not going to use it. Okay, let me say one more time. We have a memory. Memory is something like a table, many different boxes. And then the first box is the one with address 0. No matter what kind of system you are using, the first box will not be used. We reserve it and we will not give the box to any program. That is in mind. All right, Ken? So what, Desmond? So what? The interesting thing is we make use of this address 0 to represent we are pointing at nothing. We are pointing at nothing. Why? Because if we point at something non-zero, that means possible could be part of your program. But if you point at the box with address 0, definitely you are not pointing at something meaningful, because from my understanding, no one can use it. No one can use it. Okay, so this is the first concept. Everyone, listen carefully. If you have a pointer that store null pointer, that means you store the address 0. Then I know for sure you are currently pointing at nothing, because no program can get that box. Is it okay, everyone? If you understand this, please say yes. Okay, good. Then take a look at this. P point at null pointer. That means P store address 0. If I do dereference P, do you think that I am going to get trouble? Please say yes. Why? Come on, from my understanding, if P store address 0, dereference it, that means you reached the box and you try to put in a value 1. Bad guy na. As far as I know, nobody can use that box, right? Then you try to access that box and put in 1. Ridiculous. Definitely trouble. So what kind of error we are going to get? Runtime error. Runtime error. So this is exactly the reason why when you dereference a null pointer, we get trouble. Okay? I am not sure whether your 2011 instructor told you this. Why dereference null pointer you get trouble? The simple reason is you cannot use that box. This is the agreement. All right. So if you don't follow the agreement, then bad guy, crash your program. Okay. Do you know what I'm talking about, everyone? Yes. Okay. Hey, then what are we doing here? If not P, very strange. I don't know what you are saying, Desmond. Yeah. And if P is null pointer, not null pointer, that means true. In other words, you can treat null pointer as something false, Why? You should know. Because null pointer means address 0. Address 0. So 0 in C++ means true or false? False, right? Then not null pointer. That means not false will be true. Then you output this one. All right. So this slide, I just want to introduce you one weird guy called null pointer. Remember, this is something equivalent to address 0. Address 0 is the first box in the memory. We will not use it. You are not allowed to use it. Okay? Okay, question. In star P equal null pointer P minus minus. Wow, very good question. Very good question. Illegal. This is illegal. Yes. Very good question. Wow, this is something fun. Cool. Okay. And later on, I will tell you why we need null pointer, because null pointer can help you. Okay. Example, we have a pointer variable P, and we put null pointer in P. So essentially, we put in address 0. Okay. Can we print address 0 on screen? Yes. Print the address 0. Definitely no problem, right? Just like I know someone's address, I can print it. No problem, no error. Okay, P, is it a variable? P, is it a variable? Please say yes, because P is a pointer variable, a box. Can you grab the address of P and print it on screen? Definitely yes. P is a pointer variable. That means it's a box. A box has address. Grab the address and print it, no problem. And the only thing you cannot do would be asterisk P. As mentioned, P points at the first box in the memory. The reference P means start from P, follow the arrow once, get the first box in the memory. No way, nobody can access it. You shouldn't access it because this box, we are not going to use it. Runtime error. Is it okay? So far, so good? Wow, today less people come. We only have 39 students here. I don't know why. Oh, I know, Friday. Friday. Yeah, it's Friday. Okay, now, new stuff. Memory allocation. Memory allocation means what? We get memory from our computer. We need memory so that we can get boxes, so that we can store values in them. Agree? Okay, but in terms of getting memory, we have two different styles. All right. One is we get the memory when we compile the program. We get the memory when we compile the program. Okay, this is one style. Another style is we get memory when we are executing our program. Okay, so bear this in mind. You want to define boxes, right? That means you want to get memory from your computer. Two different styles. Get the memory when you compile the program, or get the memory when you are running the program. Okay, terminologies. If you get memory when you compile the program, we call this static memory allocation. Static memory allocation. Okay, what if you are running the program and you get memory from your computer? We said that we are doing dynamic memory allocation. Yeah, these two terminologies are used for what? For you to show off. Okay, nothing really interesting. Okay. Hey, but when we talk about dynamic memory allocation, that means the second style. we are going to see one word, new. Actually, new is a keyword in C++ that get memory from your computer when the program is running. Okay? That means when you put new keyword in your program, and essentially we only get the memory when the program is running. And what if I create variables without using new? Then you get the memory when you what? When you compile your program. Exactly. Yeah? Is this difficult? I don't think so. I think this is something simple. So bear this in mind. In terms of syntax, if you use new keyword, you are going to get the memory when your program is running. This is called dynamic memory allocation. Okay? But what if you define boxes, you define variables without using new? Then you get the memory when you compile the program. What's the term? Static memory allocation. All right. Remind you, when you use new to get memory, you get the memory when you are running the program, right? And one drawback, you should return it back to your computer when you don't need it, or when you are about not able to access it. Okay? So how to return the memory to the computer using which keyword? Delete keyword. So bear this in mind, everyone. If you knew something, you must do delete. In other words, one new, one delete. Okay? Everyone, if you only have new in your program, but without putting the word delete, what does it mean? I think you learned this before. Memory leak. All right? And what if you did not put new, but you put delete? You are going to get runtime error. Why? It's just like you did not borrow a book from the library, but you returned the book. What are you doing? Are you crazy? No, runtime error. This is something doesn't make sense. A donation. Okay, don't think too much. Very good. All right. Do you understand this? All right, next. Wow, what is this, Desmond? This picture shows you the structure of our memory. And in other words, I'm telling you, there are many different parts in our memory. There are many different parts in our main memory. All right. So we have one part of memory that used to keep the program code. So we call this program memory. There is a part of memory called program memory. We use it to keep our program code. Okay? Okay, we have another part called data memory. Data memory will be used to keep the data, of course. Keep the data. That means when you get a box from our memory or from our computer, you get a box from this region. Okay? So what, Desmond? Okay, more. But if you take a careful look at the data memory, there are 3 different regions: global, heap, and system stack. All right? Wow. Why 3 different regions? Because different behavior. If you put 3 parts, that means 3 different parts of memory, they have different management strategy. They have different management strategy. All right? Hey, could you guess? Which part of the memory are we going to use if we define global variable, global variable, global variables? Yeah, you're so clever. How do you know? Global. Yes. If you define global variables, you are going to obtain memory from this part. Okay, what about you define local variables? Local variables, stack. You are going to get memory from system stack. Okay, last one. If you do new, if you get boxes using new, then you only get the memory when you are running your program, right? Which part are we going to get the memory from? The last part, the last part, the last part. Heap. Okay. So again, why 3 different parts? Different memory management strategy. Okay. In other words, if you get memory from heap, then it's your responsibility to return it back to me. But if you get memory from global or system stack, no need now. I will monitor the memory. I will get it back if you cannot use them. Do you know what I'm saying? Do you know what I'm saying? So some people says that if we get memory from heap, that means it is our responsibility to return it back. Our computer will not monitor the memory. Okay, but if you get the memory from global or stack, then computer will be the one to responsible for taking care of the memory. If you cannot access them, then that's the time to collect all those back to the computer. All right. Is it assembly code in a program memory? Program memory. Okay, very good question. Actually, binary code. Binary code. Actually, binary. Yes. Good. 10. Hey, so far so good, everyone. Do you know what I am saying? Is it clear? Okay, thank you very much. Thanks. Okay, next one. Wow. Hey, we create variables X and Y without using new. Without using new, correct? Then we get the memory from which part? Careful. This question is really tricky. You need to ask me where you put this 9. Where you put this 9, Desmond? If I says that we put this out of class and functions, then which part? Global. Clever. If I put this in function, then which part? Stack. Hey, you see, be careful, huh? Be careful, huh? No problem? Okay, and we know that we are going to get the memory for X and Y when we compile the program. So this is static allocation. Hey, how about this one? In star P, we define variable P, right? Pointer variable P, pointer variable P, without using new, without using new. Without using new means we are going to get the memory when we compile the program, static memory allocation. Agree? Very simple. Okay, question. Well, why does CPP differ, global variable and local variable on memory allocation? Very good question. As mentioned, different memory management scheme or different memory management strategy. Yeah, different. It's different. Yeah, and of course, we haven't talked about this part, all right? But different management strategy. Okay, and the next one, if you use new keyword to define or to get a box or to get an array, then we are doing dynamic memory allocation because we are going to get the memory when we run our program, okay? When our program is running. Easy. Okay, now, we says that we could use a new keyword to get memory when the program is running, right? What's the syntax? Easy. New keyword and tell me what type of box you want to get. All right, for example, new int or new double or new chart, no problem. Okay, then what new does will be we get the memory for you and return the address of that piece of memory to you, then there is only one thing you could use to keep the address. What is it? Pointer, of course. Then that's why you put asterisk in the middle, left-hand side a type, right-hand side a name, define a pointer, and keep the address. Okay? So example, new int. Hey, computer, I want to get memory from you. And the memory is for int type variable. Okay, then I get the memory for you. This is it. Essentially, I give you the address of this guy, and you need to keep it in a pointer. So I do this, asterisk in the middle, int, and p equal. Okay? Hey, everyone, can I draw you a picture for this one? Int star p equal new int. Can I draw you a picture? Okay, new int. I get a box from our computer, and we get back the address of this guy and keep it in a pointer variable p. That means I know your address. Okay? Hey, you know how I call this guy? In layman term, poor guy. I call this poor guy. Hey, but poor guy looks very happy, huh? Hey, you know why I call this guy poor guy? The reason is this guy has no name. This guy, no name, no name, no name. What we know about this guy will be the address of this guy. At this point, only P knows the address of this guy. Okay? Do you know what I'm saying? Okay, and now suppose for some reason P is gone. P is gone. Then from now on, no one knows the address of this guy. Then this is a real poor guy. But don't forget, this box is obtained using new, right? We need to return it back, right? But do you think that we can return it back? No, because no one knows the address of this guy. No one knows the existence of this guy. This is a real poor guy. Hey, I hope I explained the idea clearly to you. Okay, good. Is P a local variable? Very good. It depends on where we put this statement. If we put this statement in the file, outside all the function, outside all the class, then this P is a global variable. But if we put this line in function, P is a local variable. Okay? Yes or no? Ken? Everyone, again, new int. I get a box, no name. And what we know about this guy is the address of this guy. But let's say I am naughty. I don't put it in a box. I don't keep the address in a box. So what happened? Everyone, what happened? If I simply put new int semicolon in the program, nothing here. This is absolutely legal. This is absolutely legal. This is something legal. So we get memory leak already. This is a real poor guy, right? Yes, of course. Why? No name and no one know the address of this guy is really poor. Yes. So if you want to create memory leakage, very easy. You just put new int, semicolon. That's it. Definitely memory leak. Definitely. Okay? Yes? Hey, this is how we check. This is how we check whether the memory leak detection tools works or not. Do you know what I'm saying? Okay. Next question. So new actually is a function with return type. Yes, exactly. Exactly. I will tell you what is new. New is actually not a keyword, not only a keyword. Okay, good question. Okay, one more, because asked by one of your fellow classmates. Everyone, pointer variable. I can definitely create a pointer variable without using new. Are you agree? Yes or no? Yes, definitely. Because of what we have been doing will be get back a pointer variable without using new. Now, the next question is, can I create a pointer variable using new? Can I create a pointer variable using new keyword? Yes, right? How? Yeah, you put the type here, right? New install. That means, hey, computer. I want to get a box which is install type. Quiz. I want to keep the address of this guy. Everyone, what do I need here? Definitely a pointer. Asterisk in the middle. What's the type? Install here. So basically, altogether, you have two store and then the name. Yes, are you happy? It's easy. Now you know exactly what to do, right? Now this is a piece of cake. Not difficult at all. Based on the syntax, based on the format. I do think that telling you the format of a pointer declaration, the format of the reference is really important. What do you think? I think so. But I don't know whether you would agree. Yeah, thank you. Yeah, it's good. It's really, really cool. All right. Okay. Now, example. Install P, we get this guy. New int, I get this guy. This guy is a poor guy, no name. But we get back the address of this guy and put it in P. So that's why I know your address. Okay? This is the pictorial description of all this. Yeah? Okay, everyone. But this is something new, probably. Do you think that if you put new keyword to get back a box, it's guaranteed? Do you think that if you use new, we must get back something? Please say no. May not be. Why? Because if you do new blah blah, your computer will help you get memory from heap, right? But what if no more available memory? Then you cannot get the box. But how computer let you know no more box? Everyone, if you do new int and running out of memory, I don't have memory, then I cannot give you a box, right? How computer let you know this is the case? Then return null pointer to you, null pointer to you, null pointer to you. So P would keep null pointer. So essentially, you can check P and see whether it is null pointer. If it is null pointer, that means no memory. But if you see non-null pointer or not null pointer, definitely you get it. Do you know what I'm saying? Okay? By the way, am I going too fast? Am I going too fast? No. It's okay. Good. Everyone. Tricky question. If I cannot get the memory from computer using new, then what should we do next? Again, if I cannot get the memory from the computer using new, then what should I do next? Add RAM. Good. But suppose no more RAM, restart computer. No. What about program? Can we still proceed to run other statement? No, definitely no. Why? The reason is, you get the memory, right? That means you need the memory to complete some task. That means if you cannot get the memory from your computer, then you cannot handle the task. Then you should terminate the program. If you can proceed to execute further statement, that means you are playing. You don't really need the memory, just for fun. Do you know what I'm saying? Does it make sense? Does it make sense, everyone? Do you know what I'm saying? Again, you do new blah blah. That means you need memory to handle some task. But somehow your computer is running out of memory. You cannot get back a box. In other words, you cannot continue to handle the task. Then you have to stop your program because you cannot do further. If you can do further, that means you are playing. You don't actually need the memory. Does it make sense to you, everyone? Yes? Okay. Very good question, everyone. Let me answer this question in a minute. So we do this. If P is null pointer, that means no more memory. And then we let the user know memory allocation not successful. Exit 1. That means stop the program. 1 here means error. If you want to exit or terminate the program peacefully, then what should be the value here? Everyone, do you still remember? 0. Exactly. Okay, now go back to answer the question. What is the advantage of dynamic memory allocation? Listen carefully. Dynamic memory allocation means using new, right? When are we going to get the memory? When are we going to get the memory? When? When the program is running. Okay, good. In some situation, I should only get memory when the program is running. What? Again, in some situation, I should only get memory from our computer when the program is running. Let me give you one example. Suppose I use image processing software like Photoshop or Paint. Okay, I click File, Open, and select an image, right? Yes or no? When you select an image, then that's the time we know the size of the image. Yes or no? That means before an image is selected, you don't have any idea about the size of the image. Agree? You only select the image so that we would be able to understand or know the size of the image. Agree? Then that's the time for you to obtain memory from the computer so that we can keep all the color information of the image. Agree? In other words, this is something that you have to be done in runtime. Yes or no, everyone? Do you think it makes sense? Do you think it makes sense? Hey, is it possible for you to do this? When I am writing the program, when I write my program, I know for sure in the future, you are going to open up an image 1024 times 648. Do you know this? Are you fortune teller? No, right? You have no idea. So that's why you should let user choose the image. Of course, when the program is running. Then you know the size, then you get the memory from the computer at that time. Yes or no? Do you know what I'm saying? Hello? I know it's tough, huh? Is it okay? Yeah, okay, good, very good. Thank you very much. Yeah? Okay, another question is, do you know how many students do we have next year? No, right? I want to know, but I don't know. So that's why you need to write a program that you ask the user to input the number of students. And at that point, you get memory from the computer so that we have enough boxes to keep all the scores of students. Okay, yes or no? Using new. Does it make sense? Okay. Friday, holiday mood, holiday mood, holiday mood, mood. Okay, good. Okay, Desmond, you say that we need to return back the memory, right? How? Using delete keyword. You just need to put delete keyword and put the guy who know the address of the poor guy. Again, how to return back the memory to the computer? You need to put delete keyword and then put the guy who knows the address of the poor guy here. Okay, example, int star p equal new int, right? So picture, p, poor guy here. I know your address now. Okay, now, I don't need it. I don't need the poor guy. Okay, then I put delete. What should I put here? You need to put the guy who knows the address of the poor guy. Who knows the address of the poor guy? Who? P, of course. So delete P, semicolon. Remember, delete P doesn't mean that you want to kill the box P. You are killing the box pointed by P. You are killing the poor guy. Okay? That means after this statement, P is still alive. Yes or no? Yes or no? Please say yes. So this is a common error. Remember, delete P doesn't kill P. Delete P actually kills the guy pointed by P. That means the poor guy. All right. Hey, everyone. Can I do this? Should we do this? Some of your seniors, they did that. Picture, int A. Int star P. Grab the address of A, put it in P. I know your address now. Delete P. That means kill the one pointed by P. Kill the one pointed by P. Kill this guy. Come on. Is A obtained from your computer using new? No, right? Then you shouldn't do this. Only those that you get from computer using new, you should return it. For those that you get back without using new, no. Is it okay? Yes or no? Oh, don't kill me. I have a name. Yee. Very good. All right. Hey, feel free to stop me if you have trouble. Okay, this is a bigger program. So I do this. New int, I create the poor guy, get back the address of this guy, and keep it in pointer variable P. But to play safe, I check whether P is null pointer or not. If it is not null pointer, that means I get the memory. If P is null pointer, that means no memory. Then I should let the user know memory allocation not successful and exit the program. Okay. Then if you reach here, that means you get the memory, right? You get the memory, right? Then you do the reference to reach the which guy? Layman term. Poor guy. Yes, asterisk P is poor guy. Why? New int star P. New int, return the address of the poor guy and put it in P. Okay, so asterisk P, start from P. One asterisk, follow the arrow once. Get the poor guy, put in 100. All right, and then print at P. We print the address of, are we printing the address of P, or are we printing the address of the poor guy? Are we printing the address of the poor guy, or are we printing the address of P? If we see our P, printing the address of the poor guy, poor guy, okay? And then space, and print is the value. This is the poor guy. Start from P, follow the arrow once, 100 here. Okay, I finished using poor guy. Let's kill it. So you put delete P. Delete P actually kills the thing pointed by P. So kill this guy. Okay, like this. Some of your fellow class may ask me to draw a picture to represent this one. Yeah, very happy to do it. Sorry. New install. You get a poor guy. What type of the poor guy? What type is it? Install. Install star P. I have another box P. Grab the address of the poor guy and put it in P. I know your address. So in terms of picture, you cannot tell the difference, right? But I know that the type is install. And the type of this one, install star. Agree? Yes or no? Hopefully the page is good. Yeah. Okay, now let me tell you how to obtain an array from the computer using new syntax. New keyword, put the type of the array here and put square brackets and put how many boxes you want to get here. And then the address of the first box of the array, the address of the first box of the array is returned, and keep it in a pointer variable. Okay? But let's say you don't need the array, you need to kill it because we get it using new, right? If you don't need it, kill it. You need to put this, delete. Square bracket is a must. And put down the guy who knows the address of the array. All right? This square bracket is absolutely important. Some students ask me, what if I don't put it? Good luck. Good luck. Some operating system may not give you trouble, but some operating system give you trouble. So good luck. If you remove poor guy, the poor guy is one box. You don't need to put square bracket. But if you kill the whole array, many boxes, then it is a must for you to put square bracket. All right? Don't take risk. Don't take risk. Okay? Okay. More. Question. Can we do this? No. No, 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 no. In C++ standard, this is absolutely wrong. Okay? You may say, hey, I have used one thing called def C++. I can do this because def C++ is a bad guy. This tool doesn't follow the standard. Okay? Don't take risk. Don't take risk. Don't take risk. Okay? Yes or no? Then it is a must for you to specify a literal here or a constant variable. If n is constant variable, it's okay. But if n is non-const, no. So remember, if you create an array without using new, then it is a must for you to put a value, a literal in square bracket to specify the size, or a constant variable there to specify the size. Okay, how to fix this? Put const here. Then it is okay. All right. Okay, question. How does a delete remember how many bytes to release? Very good question. Very clever. When we do nil, actually, we do bookkeeping. That means we keep it. We keep how many boxes have been created. So we know exactly how many bytes to release. Okay. Oh, do you want to learn more, everyone? One more thing. Do you want to learn more? Okay, good. Very funny. Okay, picture. New ins 5 boxes, and the address of the first box of the array is returned, and keep it in P. That means I know your address now. Okay, good. Now I'm playing. You know that we can do addition, right? So if I do P++ in terms of position change, what happened? We point at the second box, huh? Yes or no? Yes or no? Then I do this. Can I do this? No, don't do it. When you return the array using delete, you have to make sure that the pointer should point at the first box. If you change it such that it points at different box, and if you do delete, good luck. Some trouble. Do you know what I'm saying? So don't be naughty. Don't be naughty. So even you do something naughty like this, you need to move the pointer back to, back to where? Back to the beginning, back to the first one. Okay, you learn more. Thank you. Very good. Happy, I guess. Okay, everyone, this is a program demonstrating how to define an array using new. So we have this, in star P. New ins 10. We have an array, 10 boxes. Okay, I'm lazy. 10 boxes. And the address of the first box is returned, and keep it in P. I know your address. Okay, but to play safe, I need to check whether I really get the array. So if P is null pointer, no memory for you, then we let the user know memory. Yeah, all location. This is not application. Bad guy in a decimal. Memory allocation not successful, and terminate the program, right? But if we could reach here, that means P is not null pointer. That means we do get the array. All right, then we start using the array. I equals 0, I less than 10, plus I. Everyone, P is pointer. Can we use square bracket with pointer? Yes. Pointer is the real thing that could use square bracket. So Pi equal I, that means P0, the first box, put 0. P1 equal 1, second box, put 1, etc. Okay, and we also print it on screen. Okay, now we finish using the array. It's time to queue it. So remember, you want to queue the array, right? So delete square bracket is a must. And put the guy who knows the address of the poor guy. P. Done. Okay. Yes or no? All right, this is a real example. And actually, this is the example that I mentioned earlier. When to use new? When to use new? First, if the size of the array should depend on the user. If the size of the array should depend on user, then you must use new, because when the program is running, then the user can specify how big the array is, right? Then that's the time to get the array. So you use new. All right, scenario. Int n, I create a variable n, int type, from the user, how many students? And then grab the number and keep it in n. Okay, and then we do new int n. We get that number of boxes as an array, and then the address of the first box is returned, and keep it in pointer variable grace. And then we go through the whole array. How? We prompt the user, input the mark for student Papa, grab the mark of the student and put it in the box. That means get the mark of the first student, put it in the first box, get the mark of the second student, put it in the second box, and so on and so forth. Okay, and then do something else here. I don't know. Let's assume you may compute the average, you may compute the standard deviation, I don't know. And suppose this is done, and then that's the time to queue the array. Remember, queue the array, right? Delete square bracket. And put the guy who knows the address of the poor guy. Grace. Mission complete. Okay? Good. Okay. This one. Dangling pointer. Dangling pointer. What is dangling pointer, everyone? Hey, take a look at the picture. Int star p. Yeah, I have a pointer variable p. Int star q. I have a pointer variable q. New ints. I create a box. Poor guy, no name. But the address of this guy is returned, and keep it in p. I know your address. Okay. Q equal p. That means p store the address of this guy, poor guy. This is the address of the poor guy. Put it in p as well. Sorry, put it in q as well. That means I also know your address. So now p and q both pointing at the poor guy. So what? Next page. This is a better picture. This is a beautified version. All right, keep going. Delete p. Delete p means q the one pointed by p. Q the one pointed by p. You know. And p equal null pointer. Okay, that means null pointer. All right. Then Q is what we call dangling pointer. What is dangling pointer? Dangling pointer means a pointer that stores the address of something that has been returned. Again, dangling pointer means a pointer that stores the address of a guy that has been returned. In other words, this guy has been killed. Why you still miss him? Okay, so this is dangling pointer. And if you do this, this is absolutely nonsense. Asterisk Q. That means start from Q, asterisk, follow the arrow once, You still read this box and put in 10? Do you think this is possible? No. Why? You have returned this box to your computer. Maybe this box has been allocated to other program. So what are you doing here? You try to use the box that may be allocated to other program. Bad guy, you corrupt my data. Do you know what I'm saying? Do you know what I'm saying? So it is not a good idea to leave a pointer dangling. All right. So remember, you need to set all those pointer to, to what? To null pointer, exactly. To null pointer, exactly. All right. This is a common error. This is a common error. Like this. Q this guy point at null, right? Null pointer. Okay, some students do this. Asterisk Q equal 10. You may get trouble, as mentioned. But some students said, Desmond, I run this program at home. No problem. No error. No runtime error. But when I run this program, the same program in lab machine, runtime error. Why? Oh, I know. Virus. Don't think too much. The reason is, maybe your computer is not running a lot of program. So even you return it back, this guy hasn't yet been allocated to other program. So even you access it, maybe okay. But if you run the same program in the lab machine, our lab machines are running a lot of program. So very likely, if you return this box back to the operating system, this box has been allocated to some other program already. Then if you do this, kill your program. Do you know what I'm saying, everyone? Do you know what I'm talking about? So that's why some student complain saying, hey, you see, I can run my program at home. How come you deduct marks? Bad guy, ne? This is the reason. All right. So value of Q still the same. Yes, in this case, still the same. Still keep the address of the poor guy. And actually, this is bad because the poor guy has been queued. It's not a good idea to still keep the address. All right. Hey, but of course, if you don't do this, no problem. You are not going to get your program crashed. Yeah, do you know what I'm saying? But this is really bad. This is very risky. Good luck. And this is exactly the reason why. You run the same program in machine 1, no problem. And you run the same program in machine 2, GG. Don't blame. Okay, this is not something related to virus. Nothing about virus. Okay? Okay, like in some machine, the guy can be queued and still belong to the program. No, actually not yet being used by other program. So even you try to access it, your operating system don't kill your program. All right? Do you know what I'm saying? But this is lucky. This is lucky. Don't take risk. All right? Okay, another one is memory leakage. And of course, I need to draw a picture. Huh? Yin star P. Yin star Q. New int. Get the first poor guy. The address of the first poor guy is returned and put it in P. I know your address now. Huh? New int again. I get the second poor guy. And the address of the second poor guy is returned and keep it in Q. I know your address. Okay, so now we have two different pointers pointing at two poor guys. And this is a beautified version because my drawing is really bad, I know. Okay, now Q equal P. P, keep the address of the first poor guy, right? So essentially, this is the address of the first poor guy. You put the address of the first poor guy to queue. That means, I know your address, but now the second poor guy, GG, no one knows the address of the second poor guy. But remember, this guy is obtained using new, right? But now no one knows the address of this guy. Do you get a chance to return it back using delete? No, this is what we mean by memory leak, memory leak, memory leak. Okay, good. Story, not sorry, story. Some of your senior asked me, Desmond, suppose my program caused memory leak. But if I kill my program by pressing the cross sign, I kill my program, are we going to return all the memory back to the operating system? Yes. Okay, good. Then from now on, I don't care about memory leak. Why? Because at the end of the day, I'm going to kill my program, right? Who cares? What do you think? Hey, do you know what I'm saying? Let me tell you, there are some programs keep running for several years, non-stop. Then if your program caused memory leak, you lost memory more and more and more and more and more. Eventually, most of the memory are gone, right? Then do you think that you are still able to run the program properly? No, crash. Okay, give me an example, Desmond. Have you heard about one thing called web server? Web server. Web server is actually not a hardware. When you see the word server, you are going to think about, oh, okay, machine, hardware, but may not be. Web server is actually a program. What is the use of this program? When you open up a browser, you put a link, then we send a request to this program to get back a web page to the browser and show it. Okay, so do you think that we shut down the web server all the time or every day? No, we don't shut down or we don't kill the web server, because once we kill the web server, if you go online, check the web page in the midnight, doesn't work. So in other words, this kind of program, we seldom kill it. This kind of program run 24 hours a day, 7 days a week for a few years. So if you get more and more memory leakage, then GG. Is it okay, everyone? Are you happy with this? Okay, thank you. Yeah, I thought you were going to say, shut up, Desmond. Too much. Okay, thank you. Okay, so this line, we just want to remind you, memory leak is bad. Don't forget to return back the memory to your computer, please. Okay, for sure. We are going to check memory leak, for sure. We are going to check your program and see if there are memory leaks. Okay, make sure there is no memory leak. Okay, wow, done. Not yet. We still have another set of lecture notes, but I'm able to finish it on time. I'm pretty sure, because the second topic will be short. What is the second one, everyone? Oopsie. Reference, exactly. Let me finish the second part. This set of lecture notes, 17 pages. Excluding the cover page and also the ending page, we should have around 15 pages. All right. Okay, so the second topic will be references. References are also something very important in COM 212. Okay, and this is something popular. Many programmers, they use it all the time because this is so cool. Okay, first of all, what is reference? Reference is alternative or another name. That means nickname. Nickname. All right. So remember, from now on, if some people ask you, hey, in C++, what is reference? You should say, just a nickname. Just a nickname. Okay, good. Now, next question is, how to define a nickname? How to define it, Desmond? Easy. Ampersand in the middle. Left-hand side a type. Right-hand side the nickname. And don't forget, you need to put equal and tell me which variable is going to accept the nickname. It is a must to specify which variable would get the nickname. What if you only put this part and semicolon? Compilation error. In other words, you cannot define a nickname and do not tell which variable is going to get it. No way, this is wrong. Okay, do you know what I'm saying? Okay, now, why two different versions, everyone? Because I'm going to tell you, no matter which one you put the ampersand close to, same. Ampersand close to type, ampersand close to name, same, exactly the same. The spacing is not important at all. Okay? Example. Int j equal 1. Like this. Okay, this one is what? I define a nickname R. How do you know this is a nickname? Because ampersand in the middle, left-hand side a type, right-hand side a name, then this is nickname, nickname R. Nickname R, give it to J na. Ah, J, you are lucky. From now on, you have two names, J and R. Okay? Next, int x, we have another variable x. R. R means this guy na, 1. You put 1 to x. Now, R equal to 2. Who is R? R is here, this box. Set it to 2. J equal to 10. Which one is J? This one. Set it to 10. So in other words, no matter which name you use, R or J, always refer to the same box. Okay? So don't be scared, everyone. Do you still remember how many different uses of AND in C++? How many different uses? 3? Yes. Logical AND. Use AND to define nickname and address of. All right? Okay, question. Can J have one more nickname through code involving R? Yes, 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 yes. Okay, good question. Let me tell you. Like this, right? Now this box has two names. I can give one more. Int and K. I can put R or J here. Put either one. That means same box. Get one more nickname. Okay? Hey, for those of you who cannot accept this idea, think about what we have in real life. For example, my name is Desmond, right? I'm Desmond in Hong Kong, UST. Maybe if I go to CUHK, my name is Peter. Who knows? The same thing, but different names, right? Can, no problem. Oh, okay. Sorry. I take it back. Don't tell the department head. Yeah. I won't go to CUHK. Yeah, I stay here. Wow, risky. 誒，小心講話，對吧？要小心講話，小心講嘢啊嘛，好危險啊，世界好危險啊。Yeah, off topic. Yeah. Okay, next. Yin's j equal to 1. Very easy. Yin's j equal to 1. Yeah. Okay. Define a nickname R1 and bound the nickname R1 to J. Okay, now this is an error. Can anyone here tell me why this is an error? You define a nickname without bounding it to a variable. So this is an error. Okay, revision. We have something very similar to this one. That means we have another thing in C++ with similar behavior. What it is? What is it? No? Const, exactly, constant variable. Constant variable, once you define it, you should put equal a number immediately. You cannot say, let me create a constant variable, but I will tell you what would be the value later. No way, bad guy. Okay? Yes? Okay, now let's do this one. Yin's j equal 10. Define a nickname R and bound it to J. One more name. Yin's K equal 50. K 50. Okay, R equal K. Everyone, dun, 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 dun. Many of your seniors thought that we bound the nickname to K now. No, 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 no. R equal to K. R equal to K. R equal to K. Doesn't mean you want to bound the name R to K. This is what? K is 50. You assign 50 to the box, name R. That means this one. Okay? In other words, I'm telling you, once you define a nickname and bound it to a variable, it's forever. You cannot take it back and give it to other variable. No way. Don't think too much. Okay? Okay, this one. What is this? Here, I show you two different uses of ampersand. This is what, everyone? This is reference. We use N to define a nickname I and bound it to J. But what is the use of this one then? Address of. Just want to remind you again and again and again. Different uses of AND. Okay? All right, everyone. Why this is wrong? Int J, absolutely okay. Int and I define a nickname I, but I bound the nickname I to an address because NJ means an address, right? Can you bound a nickname to an address? Could you bound a nickname to an address? No, 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 no. So this is wrong. This is wrong, absolutely wrong. But this is okay. Wow, what is this? Desmond, I love it. Wow, yin star and ref, yin star and ref. Like this. Int J, define a variable J in type. I grab the address of J and put it in a pointer variable P. Okay, everyone, is pointer variable P a variable? Is pointer variable P a variable? Yes, right? Variable. Then we can give the variable one more name. Okay, how? Like this. And right, left-hand side, the type, right-hand side, the name. And then we need to specify which guy accept the nickname. Okay, let's say now the nickname is REF. Let's say P is going to accept the nickname. P is pointer variable, accept the nickname. Then what should we put here? Check. What's the type of P? Check. What's the type of P? What's the type of P? Whole thing. In star. So what should we put here, everyone? What should we put here? In star. Then you see something scary. In star and ref. Yeah, it looks scary. But who cares? It's fun. Do you know what I'm saying, everyone? Yes? Okay, let me check whether you really understand this concept. I want to give one more name to P. I want to give one more name to P. I want to give one more name to P. Tell me what to do. And in the middle, left-hand side a type, right-hand side a name, and then which guy is going to accept the nickname? P is going to accept the nickname. Huh? Let's say the nickname is ref. Then what should we put here? Check P. What's the type of P? Whole thing. This is it. This is scarier. In star, 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 and or EF equal P. Okay, I'm pretty sure that if you show this to 2011 student, you scare them. I want to drop the course. Can I do it now? Okay. So far, so good. So far, so good, everyone. Good. Okay. Wow. Fun. Hey, let me go through this example with you. Using picture. Yin J1. Feel free to stop me if you could not follow. If you could not follow. Okay. Yin star PI. We have a pointer variable PI. Grab the address of J. Grab the address of this guy and put it in PI. I know your address. Okay. This one, I define a nickname ref and bound it to PI. Okay, PI, you're lucky. You have one more name. Output J equal. What is J? 1 and then comma. Output star PI. Star PI means what? Start from PI, follow the arrow once. Start from PI, follow the arrow once. J. That means this is J. That means 1. Output this one. Asterisk ref. That means start from ref and follow the arrow once. Start from ref, follow the arrow once. J. That means 1. Okay. And then yin k equal to 2, huh? And then nk. NK means grab the address of this guy and put it in PI. Okay. I know your address. Okay. Hey, any memory leak? Any memory leak? Any memory leak? Oh, sorry. No, because this is not something created using new. Not new, right? No problem, no problem. Okay, good. J equal. Output J. J is 1. Output asterisk PI equal. Asterisk PI means start from PI, follow the arrow once, start from PI, follow the arrow once. That means K. K is 2. Output asterisk ref. Start from ref, follow the arrow once. Ref is this guy, huh? Follow the arrow once. K is 2. That's why we get this. It's nothing difficult, but you need to be super careful. Don't make careless mistake. All right? Okay. What is this? Nickname. Oh, Desmond, you are trouble. You are in trouble. You says that if you define a nickname, you must bound it to a variable, right? You haven't done so. Bad guy, nah, trouble. No, 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 no. Why? Because if you put it in the parameter, that means the nickname, is not yet defined. Is defined only if we call the function and pass something to it. Do you know what I'm saying, everyone? If you understand, please say yes. Okay? Nothing wrong. Don't get me wrong. I put in an I. It doesn't mean that I define the nickname I already. Nickname would only be defined if you call the function and pass this guy a variable. Okay? Yes or no? And I want to remind you one more thing. Everyone, before leaving the function, that means here, that means return I. You need to kill I, because I is a local variable. Why local variable, Desmond? Because I is a parameter. Parameter means local variable. Then you need to kill I. That means you kill what? You kill I. That means you kill name and term. Nickname. You kill the nickname. So you kill the nickname, right? And next time you call the same function again, then we define a new nickname. New nickname. What is it? New nickname. What is it? What is it? I. You create a new nickname I and bound it to the variable. Okay, so this is the fundamental concept. Bear this in mind. All right. Okay, now let me tell you. Why you put nickname as parameter? What is the advantage of this? Everyone, listen carefully. If you put nickname as the parameter, the advantage is you save memory. You save memory. Why? You only define a nickname and bound it to the box, right? You don't need to create a new box that occupy more memory. So this is what we call save memory. Save memory. Save memory. Okay? So remember, if you want to save memory, then you better make good use of nickname. Because if you pass something to a function and the function accepts it using nickname, no memory, or I shouldn't say no memory, you are not going to consume more memory. Okay? Yes or no? Okay? And second thing, if you put nickname as parameter, the magic is if you put value to I, essentially you can get back the value that you put in I at the function caller. In this case, main. All right. I don't know what you are saying, Desmond. Okay, picture. Int j equals 7. We start from main. Int j equal to 7. Okay, fj, pass j to I. Do you need to create a new box I? Do you need to create a new box I? No, 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 no. This is nickname. You only put the nickname I for j. You get one more name, lucky. Okay, plus I means I add 1 to this guy, 8. All right, return I. Return I means return the value 8 back here. So that's why you output 8 here. Okay, see out j. You also output 8. That means what you have done in the function also affect the one in main. Why? Because you pass j here, bound the nickname I to it. If you modify I, actually you modify which guy? You modify J also. So that's why J, like this. Okay, so conclusion. Why you put nickname as parameter? Why you put reference as parameter? Save memory. Second thing, you want to get back the value that you assign to the one with the nickname at the function caller. Okay. Hey, by the way, what is this? Do you know what is it? No, this is not cat. This is hamster, exactly, hamster. Yeah, just like me, right? Keep running. Okay, just kidding. Hamster. All right, so this line, I just want to tell you exactly the same thing in written description. All right, so no worry, same thing. All right, this line, I want to tell you why we put reference or nickname as parameter. Okay, the first one is, I want the function caller to be able to get back the value that you put in the box with the nickname. Okay, do you know what I'm saying? This is one thing. And the second reason is for efficiency. For efficiency means save memory. Okay, these two are the two that I mentioned to you earlier. All right, nothing new, nothing new. But I think this is more important. Most people, they put nickname in parentheses. That means as parameter is for saving the memory. Okay, everyone, have you seen this before? I think so. You should see something similar in 2011. What the statements do? Yeah, swap. That means you have two variables. You want to swap the content. So that's why you introduce the third box, temp, so as to facilitate the swapping. All right. Hey, let's try. Wow, lovely cat. Okay, this one. Chart A, put the character Y. Chart B, put the character N. Okay, swap AB. Pass A to Y, pass B to Z. Everyone, do we need to define a new variable Y and variable Z? Please say no. Just nickname Desmond. Bang the nickname Y to A na. Bang the nickname Z to B na. Good. Okay, now chart temp. Put Y, put the value of Y to temp. The value of Y, this guy, okay, to temp. Put the value of Z to Y here. Put it in Y. Put the value in temp to Z, temp. You see, we have successfully swapped the two box content. All right. Okay, now come back here. We print AB. So the output will be A is N. B is, oh, where's B? Sorry, I forgot to put B. B is Y. So NY. Okay. Good enough? Cool. Okay, everyone. What's new here? The new thing is this one. You have seen this already. This is what? Nickname. If you pass a variable to this guy, this is what we mean by pass by reference. Pass by reference, that means pass by nickname, right? Hey, but this is something interesting. You put a const keyword before the reference. What is it? Okay, everyone, listen carefully. This one means you cannot modify the thing referred by J through J. Okay? Wow, I know this is crazy. Const in and J means you cannot modify the thing with name J through the use of J. Okay? In other words, J plus equal 10 is wrong. I don't understand, Desmond. Okay, let's do it. Int A equal 10. Suppose this is main. And then I do this, CBCR, and then A. All right? So picture A0. You pass A to this guy. We don't need to define a new box. J is a nickname. Bound the nickname to A. Okay, this guy has two names. J plus equal 10. J plus equal 10? That means that this guy, add 10 to it. No. Why? Because, as mentioned, this const means you cannot modify the thing with this name through J. So this is absolutely wrong. All right. So why we put something like this? Because I want to tell you, if I want to pass you something by reference, that means I want to save memory. Hey, but risky. If I pass you something by reference, you save memory, but at the same time, you could modify my box. I don't like it. I don't like it. So in order to protect it, put const. Do you know what I'm saying? Do you know what I'm saying? Again, I pass a variable to this guy, and this guy bound the nickname to me. Save memory, yes, very good. Hey, but wait a minute. One thing that is very risky, because if you bound the nickname to this guy, you can actually modify this guy, right? This is what I don't like. I want to protect this guy. So you put const there. Then no modification is possible. Do you know what I'm saying, everyone? Okay, if A is a global variable, what if A plus equal 10? No problem. That means you could modify this box using A, but not what? But not what? But not J, but not J. Exactly. Or cannot modify this box in CBCR. Exactly. Good. This is win-win. I can save memory at the same time, no risk. You can modify my. Okay. So if you want to save memory, you need to pass by reference. You need to accept the thing using nickname. If you don't mind that the function modified it, no const is needed. But if you care about the modification, okay, pass this guy to this guy by reference. That means nickname and put const. Okay. Would const nickname be queued at the end? Yes. This J would be queued if you leave the function CBCR. Yes. Good question. Okay, everyone. Hey, I want to tell you something interesting here. What is interesting? I want to tell you which one is doable, which one is not doable. Suppose we have the two functions on the last line. This one by reference, this one by constant reference. Okay. We have two variables, I and j. I is int, non-const. J is int, const. I is non-const, j is const. Again, I is non-const, j is const. Okay, good. CBRI. Can we pass something non-const to something non-const? Yes. Why? Same level of protection. Non-const, non-const, same level of protection. All right. Now, pass I to CBCR. Can we pass something non-const to const? Yes. Why? We increase the level of protection from non-const to const. Better protection. Yes. Why not? So this is okay. This is okay. All right. Next. J is const. Can we pass something const to something non-const? Your turn. No. Why? We lower down the level of protection. Originally, it's const. If I let you do this, less protection, right? No. I don't like it. Bad guy, na. All right, last one. Can I pass something const to something const? Please say yes, same level of protection. So don't be scared. Just a piece of cake. You just need to check the level of protection, right? All right. Okay, everyone. I don't think I need to go through this slide. Do you know why? I cover exactly the same thing in the lecture class. Do you still remember I mentioned one thing called differences between pointers and references? Exactly the same. Exactly the same. All right. But let me briefly recap. Three differences. One is pointer can point at nothing. That means no pointer. But reference, we have to bound it to a variable. So this is a first difference. This is the first difference. Okay, second thing is a pointer can point at different thing at different time in the program, right? That means point at this guy at this point at the other guy at another timestamp, right? But reference, once you bound the nickname to one guy, it's forever. You cannot take it back and bound it to another guy. No. Third one, there are many operators. There are many symbols. Work with pointers. But what about reference? No. You could use reference nickname as usual, like regular variable. Okay, these are all the differences between pointers and references. All right. Constant member function. What is it? Is this concept same as constant member function? No, because the parameter const protect the thing that you pass to it. The parameter, the const parameter protect the thing that you pass to it. But constant member function, you protect what? Constant member function, you protect what? Data members, exactly, data members. Thank you very much. Yes, so different purposes. Okay, everyone, this is another example. Oh, constant object can only call constant member function. Perfect. Yes, exactly. We are going to mention this very soon in class. Very good. Okay, everyone, this is the last example, if I'm not mistaken. All right, let me finish this. Int I equal 1. output I equal and 1 here. So that's why we get this. All right, and I, let me grab the address of I and pass it to this guy. So we have P1. Now know the address of I. Agree? All right. Asterisk PI. Start from PI. Oopsie, this is PI. Hey, bad guy. Start from PI. Follow the arrow once. Start from PI. Follow the arrow once. This 1 plus 1 become 2. Okay, done. Hey, which one will be queued? We are about to leave function 1. Which one will be queued? Which one will be queued? PI. Done. And we output I equal this one 2. That's why we get this. Okay, now function I. We pass I to this one. Do we need to create a new variable? No, just define a new name Ri and bound it to I. Okay, Ri. Ri plus plus. Ri is here. Plus plus, add 1 to it. 3. What should we queue? What should we queue here? Ri. Go back. I equal I, which is 3. So that's why we get this. All right. The reason why I put this example is to show you we can actually achieve something using pointer or reference. And you see that I just want to add 1 to the box, right? I can do it using pointer. I can also use it. I can also do it using reference. Both are acceptable. Okay, but be honest. If you have control, which one do you like? Do you want to do it using pointer or do you want to do it using reference? Reference makes sense. You see, this is complicated, but this is clean. So that's why most people say this. If I get a chance to do something using reference, then I will always use reference rather than pointer. I only use pointer if I have no choice. Only pointer could be used to achieve it. Then no choice. I use pointer. Otherwise, I use reference. Okay? Yes or no? Okay, that's all. Thank you very much, everyone. Wow, the time now is 8:54, right? Yeah, on time. Good, very good. So everyone, that's all. And remember, I'm going to send you an email today and letting you know where could you find the exercise. I still bear this in mind. If I'm not mistaken, I said this, right? I said, after I finish the second review session, I'm going to put something online so that you can practice. All right. So I will send you an email this evening. All right. And I will also post the answer. So do work on those questions and check your answers. Okay. Thank you very much, everyone. Thank you. Thanks a lot. All right. Hopefully you'll find the review classes useful. Thank you. All right.